Hi, Les Druven here with another video involving calculation of residential heat loss and heat gain. In Canada, CSA, Canadian Standards Association, has developed a standard in which we can determine the size of furnace required to heat a home in any location in Canada. This worksheet you see in front of you has been developed to help designers complete the heat loss and heat gain so that it falls within the requirements of the standard, the F280-12. So let's have a look at page 1. This is just your standard introductory form where you've got the building location, so an address if you had one, the name of your company, the location, and so on. Building construction details would involve the number of stories, whether the house is mechanically ventilated, the weather location, which is important because without this you don't know what your outdoor design conditions will be. The front direction of the house is also very important as this affects the size of cooling equipment. Air tightness will affect both heating and cooling, and so we need to assess the air tightness of a building. Local shielding refers to how close other buildings are to the house that you are designing, or possibly your house is standing on a hilltop or on the side of a lake and could be affected by direct wind. So this local shielding is a consideration that also affects how much air leakage happens in a home. Internal shading refers to whether or not there are blinds or drapes or other type of interior shading on glass. The number of occupants, of course, is important because that goes towards the sizing of our cooling equipment. Then the bottom section involves the building envelope assemblies. Now in here you can be generally pretty general, if you will. You don't have to be overly specific. You'll notice, for instance, for the first structure, wood frame 2x6 plus brick and an R22 bat. Now obviously within that wall assembly we've got other items like plywood, airspace, the exterior air film, the interior air film, but a lot of these are common and therefore would be assumed to be included in these descriptions. And so these different descriptions also are obtained from your construction notes or information provided to you by the architect or the builder. In our example here, we've got 3 different wall assemblies. The first assembly, wood frame 2x6 plus brick with an R22 bat. That refers to our exterior exposed wall. The second is wood frame 2x4 drywall both sides with R22 plus 1-inch external insulation. This happens to be a frame partition between the house and the garage. The third structure is a wood frame 2x6 with a concrete block as well as R22 fiberglass bat insulation. This as well is another wall assembly that separates the house from the garage. The below grade walls will be 10-inch poured concrete, and our inside insulation will be an R12 fiberglass bat plus an R10 continuous layer of insulation. Our ceilings In this case, we require an R60, and we will achieve that using loose fill for attics. Our doors will be a metal door with a polyurethane core, and we assume that there is no storm door in this application. For our windows, we are choosing a pretty basic window, double glass with argon and an E-coating. Argon and E-coatings are becoming very standard in today's windows, and so it wouldn't be unusual to have these characteristics associated with the windows in your calculation. Then we've got headers, and these will be wood frame. In our case, the floor joists which make up the header are 2x8. All the headers have a brick veneer, and typically your header insulation is equal to the insulation required in your frame wall. So in this case, we will have an R22 batt in our header area. Floors on soil. We do have a basement, and this is obviously going to be a poured concrete floor. However, because it's the basement floor is deep in the ground, it's not required to have any insulation. And finally, in this particular model, we do not have any exposed floors, such as a room over the garage or possibly an addition over top of a cold crawl space. So this would be the information that you would include in page 1 of this particular heat loss calculation.